Alright, we're looking at question number 11 here. Using Bohr's equation, we want to calculate how much energy in joules is needed to promote an electron from the hydrogen atom ground state to an n equals 4. Alright, now when it says Bohr's equation, what it's talking about is actually this equation. It's provided on the periodic table I give you. It's actually in your textbook. And it is one that's provided on the actual test that I give. So you don't have to have this memorized. And that is I for initial. So it's the final level it goes to the initial. Alright, so this one says from the ground state to an n equals 4. So the 2 would be the final. That's going to be 4 then. And initial, it just says ground state, doesn't give an actual numerical value, but ground state is 1. Alright, so I need a calculator. And I didn't start that up before I actually started this recording. There it is. Alright, so get this out of the way. And I'm going to do 2.18 times 10 to the negative 18th. And I forgot to put the negative in, so we'll just take the negative of whatever answer I get. Then we're going to multiply this by the difference of, I'm going to do this, 16 inverted. And then 1 inverted is just 1, but I will just type it in, 1 inverted. And then get this. And then I just need to flip that sign and say the energy is 2.04 times 10 to the negative 18th joules. Alright, now the very next question wants us to turn that into a wavelength. We're using another equation that's on our from our book, and that is delta E equals hv, which is how we're going to turn this energy into a frequency. But I'm not actually wanting a frequency. I want the wavelength. So the other equation I'm going to use to help that out is this speed of light equals wavelength divided by frequency. I'm going to combine those to get delta E equals h times c over lambda. So I basically just moved the lambda over here and then substituted that in for my frequency. Alright, so I have that 2.04 times 10 to the negative 18th joules. H is Planck's constant, 6.626 times 10 to the negative 34th joule seconds. Speed of light is 2.998 times 10 to the 8th meters per second. And wavelength is what we're going to solve for. So I'm going to take that value we had. I'm going to get rid of that negative sign first. And then I will divide that by 6.626 times 10 to the 34th. And also divide that by the speed of light. And technically this is 1 over wavelength, so to get the actual wavelength I need to take the inverse of this, and I'm perfectly fine to record the value like that. So wavelength equals 9.71 times 10, I think it was minus 8th, negative 8th, and that will be meters, which is why we sometimes see wavelengths reported in like nanometers, because we can move that decimal that way. But this one doesn't, oh, it does say put it in nanometers, doesn't it? Yeah, see that? So that's not my answer. I'm going to multiply that value by 1 billion to get the nanometers, which is 97.2 nanometers. That is the answer. All right.